BTEC Applied Science for AAQ, one of my electricity videos for the physics, and this video is about fuses, and we're going to talk about kilowatt hours as well. So have a go at this question to start with. The last video was equations. You can do this, work it out. What current does it draw from the 230 volts main supply? And so you do this, the answer in 3, 2, 1, and there you go, 6.5 amps. Okay, this air fryer will draw a current of 6.5 amps. Now, that's the current that when the device is working normally and there aren't any problems, that should be the current that it draws from the supply. That should be the current traveling in the wires when it's working normally. If there's a fault, if there's maybe a loose wire, a wire has become unconnected or frayed or whatever, then what might happen is that the current would be a lot bigger. If you had a short circuit, then you'd get a very, very large current. And that's a problem because it could start a fire, yes, and set fire to your house, or it might just damage the device. It's quite an expensive air fryer and I don't want it damaged, okay? So is there a way that we could switch off the device if the current is bigger than it should be? And that's what a fuse does. So a fuse, it's basically just a very thin piece of metal, and when the current goes above a certain value, then this very thin piece of metal gets very hot and it melts and it breaks the circuit. So if you look at this fantastic animation that I've done, basically what I'm doing is I'm turning up the voltage so the current is getting bigger, and then when the current gets bigger than 10 amps, then this little bit of wire melts. We say you blow a fuse. It doesn't blow up or anything. It's just a very thin little bit of wire melts. But we blow the fuse and that breaks the circuit, so the current is zero, so the device is saved and there's not going to be a fire or whatever. There's a fuse in the plug, yes. There's a fuse probably in the device itself. And then somewhere in your house under the stairs, they used to have what they call a fuse box. Now it's all trip switches which do the same job, but you don't need to know how trip switches work. But it's the same principle. Yes, when the current goes above a certain value, it breaks the circuit and that saves the device and it stops fires. It doesn't stop the person getting an electric shock. To get an electric shock, I mean, to kill a person, it's like maybe 20 milliamps. It's a very small current needed to actually hurt somebody. So we're not protecting people here. We are protecting the device and your house. Now, different devices have got different powers. If you look, the little hand blender, 200 watts, microwave, 600 watts, etc., all the way up to the oven. If the oven's on and you're using a few of the electric rings at the top, then that draws a lot of current. That's 4 kilowatts, that, okay? So they should have different fuses in their plugs. Yes, and you'd be given a choice. It's usually something like either 1 amp, 5 amp, 10 amp, 15 amp, 20 amp. So which of those fuses should be in the plug of these different devices? And you will very, very probably have to work it out. And the way you work it out is you work out the current, and then you look at the current and you choose the fuse value, which is just above the current. Pause the video, do it for all of them. Yes, and I'll show you the answers in 3, 2, 1. And there you go. And that is how we work it out. We work out the current, I equals P over V, and then you choose the fuse value, which is just above the normal working current. And that way, if the current is above the normal working current, the fuse blows. Yes, breaks the circuit. Now, moving on to something else. How much does electricity cost? How much does it cost to use an electrical device? Well, how much energy does the device use? And the amount of energy that it uses depends on two things. It depends on the power of the device, and it depends on how long you use it for. Okay, the more powerful the device is, then the more energy it will transfer every second. And then the longer you use it for, then you're multiplying the power by that to get the energy. Okay, it will also depend on how much the electricity company charges you for each what we call kilowatt hour. Yeah, that's called your tariff. So energy is power times time, and we pay for energy. Now, we could do energy is power times time, joules equals watts times seconds. So if you multiply watts by seconds, you'll get an answer in joules. There is another way of measuring energy, and that's to use kilowatt hours. Yeah, we can measure energy in kilowatt hours. And very simple, a kilowatt hour is kilowatts times hours. Yeah, if you use 1 kilowatt for 1 hour, that's 1 kilowatt hour. Sometimes they just call it units, how many units of electricity, and they mean kilowatt hours. Somewhere in your house there'll be a meter, maybe under the stairs, and all of the electricity goes through this meter, and that will record how many kilowatt hours that you use. And then somebody comes round every couple of months and reads your meter. Or nowadays, they actually, the meter sends a signal, like a Wi-Fi through your Wi-Fi to the electricity company. And so you get your bill shortly after that. So kilowatt hours is kilowatts times hours. Look at this. How many kilowatt hours does each of the following use? Okay, you work it out. Very straightforward. Be careful with the units. I'll show you the answer in 3, 2, 1. Okay, so now a 1,500 watt, so 1.5 kilowatts for 2 hours, 3 kilowatt hours. 600 watt microwave, so 0.6 times 0.5. Yes, 30 minutes is half an hour. And then the last ones are straightforward. 3 kilowatts for 5 hours, 15 kilowatt hours. Okay, and here's another one. Ooh, gorgeous car. Look at that car. Fantastic. An electric car. That looks like a Renault 5. This electric car has a battery capacity of 52 kilowatt hours. How long would it take to fully charge from a 22 kilowatt supply? And the answer is, do it yourself in 3, 2, 1. Okay, so time is energy over power. So 52 kilowatt hours divided by 22 kilowatts, 2.36 hours, which is okay. 2 hours, 22 minutes, that is. 0.36 hours is 22 minutes.